Alright, hello everyone. So today we're going to be going over integration by parts. This is a difficult Calc 2 topic to go over, especially trying to solve these integrals with the definition. But there is an easier way, at least what I found easier for me. We're going to do these integrals by using something called tabular integration. So for the first example, we're going to be finding the indefinite integral for 3x squared times sine x. So I'm going to run you through how we would do this first, and then we'll go through other examples. Alright, so let's get into this. Okay, so first step to solve this problem, what we're going to do is set up a table with two columns, and we're going to put the left side to be equal to D, and then the left side, or the right side, we're going to put I. So D on the left and then I on the right. And basically D is going to stand for derivative and I is going to stand for integration. So now for this next part, you're just going to have to know from doing multiple examples which function works. From doing multiple examples, I know that I'm going to put 3x squared on the derivative side, and you'll see why. So basically we're putting this on the derivative side because I'm going to want a function that is going to be a lot easier to integrate in the future. So for integration, the other function is going to be sine of x. All right. And then, well, we just continue going downwards, and we just want to keep doing derivatives until we get an integral that's a lot easier to work with. So you'll see what I mean in a second. So derivative of 3x squared is going to be 6x, and derivative of that is going to be 6, and derivative of this is going to be 0. Alright, so this is where we're going to stop. Let me just make this a bit neater. Okay, so now we do the integration side. So for the integration side, we're going to have the integration of sine is going to be negative cosine. And then we have the integration of negative cosine is going to be negative sine. And last but not least, we have the integration for negative sine, which is just regular good old cosine. Alright, now the next step, we're going to put negatives on every other derivative mark. So starting from the second one, we're going to make it negative 6x, and we go all the way down and make this negative 0. At this point, it's actually, it's the same thing, negative 0, 0. But, to keep the process the same, let's just do it that way. Alright, so now once you've done this, this is pretty much the hard part. The easy part now is just multiplying the terms together. And to do that, we're going to go diagonal from the derivative to the integral. Derivative to the integral. And for this last part, it's going to be the integration of 0 times cosine. And you'll see what I do with that. So let's type this in. And I could probably copy this. Let me copy this. Okay. So for our first term, it's literally going to be as simple as it looks. We're going to take 3x squared and multiply it by negative cosine. So this is going to be our first term for the indefinite integral. 3x squared. Boom, just like that. Now we're going on to the next one. So it's negative 6 and negative sine. So since both of them are negative, it's going to come out to be positive. It's going to be positive sine of x multiplied by 6x. Alright, and then if you get the hang of it, you see the next one is just going to be positive because it's 6 times cosine. So cosine x times 6. And now the last part, so the reason why we kept doing the derivatives all the way to 0, you'll see now, because the last part, to answer this, we would have to solve the integration of 0 times cosine, which is just going to be 0. And so now the integration of 0 is pretty much going to be any constant. So that arrives us to our final answer, which is base plus c. Alright, so it's just as simple as that, and you can see why we kept doing derivatives until we reach 0, because 0 is going to be a lot easier to work with than if we did 6 negative sine x. Alright, so we're going to use the same method to solve other examples in this video. Alright, so let's see those other examples. Okay, so here we have our next example, and hopefully from the last one that we did, you'll be able to solve this along with me now. Alright, so first step, just like before, gonna make that column, that table column, and on the left side, we're always gonna put D first. Good way to memorize which one goes where. D comes first because it's in the beginning of the alphabet. Whoa, mind tricks. Okay. So now the next part is we pick which function goes on the left side and which function goes on the right side. Hopefully by looking at this integral we're trying to solve for, you can see it's pretty similar to the one we did before, and on the left side we're going to pick 4x cubed to be on that side. And the reason why is just like before, we're going to see this function go to 0 as we continue taking the derivative. And that leaves us with the other function just being e to the x. And let's continue now. So derivative of 4x cubed is going to be 12, if I can type, x cubed to the second. And then we continue, so this is going to be 24x. And then this one, last one, or no, second to last, 24, because it's derivative of 24x. And now the last one's just going to be 0. Alright, and this one's going to be pretty easy. So the integration of e to the x is e to the x, right? And we're just going to do this all the way down. So e to the x, e to the x, and e to the x. That never changes. Alright, so what's our next step? See if you can try to remember. That's right, if you said the right answer. So the right answer is we're going to take, starting from the second one, make all of them negative by alternating. So we start with the second one, and we skip one, just like the last one, right? And we make this one negative. So there's no more, so we stop doing that. Alright, so now that we did the hard step, this is the easy step now. Just multiplying all these terms across. Alright, so now I can copy this one, just like before. Paste. So for our first term, we see is going to be 4x cubed times e to the x. Alright, now we look at our next term is going to be negative 12x squared to the ex. And we look at our next term, and we're multiplying 24x by e to the x. 24x e to the x. And our last one going to be negative 24 times e to the x. Alright. And last but not least, we have this integration of 0. This is going to leave us at 0. At c. Alright, and this is pretty much your answer. If they want you to simplify it, basically what you can do at this point is, what we can do is, since all the terms have e to the x, we can factor out the e to the x and then type in all the terms just like before. And it will give you the same answer, but it looks a bit neater. all depending on how your professor or whoever is grading your papers want it. 24x minus 24 plus c. Alright. So I hope by now integration by parts is starting to look a little bit easier. And so let's get into our last two examples and let's see how this goes. Okay, so here we have our, let me see, third example. Yeah, third example. And just like before, it's going to be pretty much the same process. So we're going to have d on the left side, I on the right side, and then we pick a function to go on the left side and a function to go on the right side. Now in this case, especially for me when I first started doing this method, I would try to put x on the d side and then put the natural log on the integration side. Only problem is, while x is easy to do the derivative for, the integration of natural log x is pretty difficult. So in this case, what we're going to do is actually switch them around and put natural log on the derivative side and put x, oops, there we go, and put x on the integration side. And like I said before, this just comes with practice, knowing which ones to put on which side. So without further ado, let's continue. So derivative of natural log x, this is going to be 1 over x. And integration of x is just going to be x squared. And then this whole term divided. Let me see. How do I do division in this? That one. Okay. Divided by 2. Alright, so now the question becomes, how long do I keep doing this derivative and integration? Well, we keep doing it until we find out, can we integrate these two across? So with the integration methods that we know, are we able to do the integration of 1 over x times x squared over 2? And since the answer is yes, we're going to stop at this point and continue with the rest of the method. So just like before, or I skipped a step. So we're going to multiply the diagonal, and we need to make the second one always negative, right? Since there's no more to continue, we stop here. And then this last step going across is just going to be integration. So let's solve now. Alright, so now we have, just going across, we have x squared divided by, squared divided by 2 multiplied by natural log of x. Alright, and then for the one going across here, since this is not 0, the integration is not going to be c. It's going to be the integration of those two values multiplied by each other. So let me do it in parentheses first so you can see it. Do by x by 2. Yeesh, that looks ugly. Okay, that looks a bit better. Alright. So, through the regular methods, we see that we can take the integral of this. And that's all we're going to do. So, let me copy this part. Copy. Paste. And let me just simplify that integral. So, since there's an x on the bottom and the top, we can simplify this to just x divided by 2. And since there's 1/2, we can move that out of the integral. Right, using our methods like before, we can put 1/2 integral of x. Alright, so now at this point we just solve for the indefinite integral of x, which is going to be the x squared divided by 2. So, paste. It's going to be x squared divided by 2. And then we can multiply that across. So let me just draw this. We're working up here. Okay. X squared divided by 4. And always, because if you never put it, your professor will take off plus c, because this is an indefinite integral. And we had just solved this integration. So it does, with integrations like these, sometimes you do need to put the one you don't expect on the derivative side and the other one on the integration side. Other than that, the method is pretty straightforward and works for this example as well. Alright, so here we are at the final example that we're going to go over. And this one is going to involve a trick, so if you want, try this by yourself, and if you get stumped, come back to this part so you can see how it's done. Alright, we're going to continue just like before, making our table. D, I, okay. And in this scenario, it doesn't matter which one you put on which side. I'm going to put cosine on the derivative side. And then e to the x on the other side. Okay, so some of you might be thinking, now hold up, wait a minute. When we keep doing the derivative, right, so negative sine of x, and then e to the x, we ask ourselves, can we do the integration of these two multiplied across? No. Alright, so then we continue. Cosine, negative cosine. And just like integration, keep it the same. E to the x. And we ask ourselves, can we do the integration of these two across? No. Now, if you seem to be catching up with the pattern, you may say, hold on, we can just be doing this for infinity and we're never going to get an integration that we can do across. So that's why you need to know this little trick with doing these type of integrals. So this is actually where we're going to stop, and we're going to continue doing the method. So you'll see how we're able to solve only be given this, alright? So just like before, right, we make this one negative, and then we make all these multiplied across in the diagonal. And then the last one, integration. Alright. Some of you still may not believe me how this is going to get solved. Don't worry. You'll see how we do it. Okay. So the integration is going to be equal to, so we take these first terms just like before, multiply them across, e to the x, cosine of x. Alright, now the next term is going to be negative sine, so we're going to get a positive answer here, e to the x, sine of x. And then for the last one we see it's going to be minus, and this is going to be integration, so minus the integration of e to the x cosine of x. Now you may be saying, wait a minute, I feel like I'm running around in a circle. Isn't that what we're trying to solve for? Well, yeah, it is, actually. But we can actually do something really cool in this scenario. So we're going to use some algebra. And if we add this term, the integral of e to the x cosine of x, to both sides, we realize that this is going to get rid of this term on the right side. And we're going to be left with this. Copy. Paste. And since it's indefinite, plus c. Alright. Now that we've moved this integration to the left side, right, and we did that by adding this term, the integration of e to the x cosine of x, to both sides, right? So this side is going to be 2 times, and this side is going to disappear. And now all we need to do is just, like before, algebra, to get the 2 to the other side. So to do that, we're going to do the derivative, not derivative, we're going to do dividing. And that's going to leave us with, let me see, how can I do this? That's divided, yes. You can never tell with the program. Alright. And this is your final answer. So anything that repeats, like e to the x cosine of x, integrations like these, you need to know this little trick in order to solve for them. Other than that, all of them should be pretty straightforward. And I hope you're able to do integration by parts a lot easier now. Alright. If you like these videos, be sure to like, and be sure to comment any other videos you would like me to make. Alright, thank you.